Welcome to 5-Minute Math. This is Carrie Rhinehart. Today I'm going to be looking at Algebra 2, Unit 2, Lesson 6, which is writing polynomial functions. So when we're asked to write a polynomial function, you are usually given the factors or the roots and possibly a leading coefficient. And then you have to write a function of least degree that would match up with that information. Now when they say of least degree, they're just saying assume that there are no other roots than what you're given. Okay, so assume that everything you're given that's all there is. So for example, and if you're following along in the text, I'm just looking at example 1. Let's say that they give us that there's roots at, let's say there are roots at 2, -3, and 4, and a leading coefficient of 1. So in order to write the function, we have to use factored form. So remember, factored form is if there's roots at 2, that just means x equals 2, there's x equals -3, and there's x equals 4. But factored form means you get each of these equal to 0. So for the first one, I'd subtract 2 from both sides, and I get x minus 2 equals 0. The next one, I'd have to add 3 to both sides to get that equal to 0, and then subtract 4 from both sides. So my factors are x minus 2, x plus 3, and x minus 4, and my leading coefficient is 1. So my function of least degree would be 1 out front for leading coefficient, and then I'd have my factors at x minus 2, x plus 3, x minus 4. Now, the order does not matter here. Now, you may also be asked to actually simplify this out, FOIL or distribute, but you guys know how to do that. FOIL those out, simplify, and then you could distribute the x minus 4. I'm not going to do that here. If you need help with that, you need to go back to Algebra 2, Unit 2, Lesson 1. It's just a reminder, actually Lesson 2, Operations with Polynomials, if you forgot how to multiply those out. All right, now another thing you need to know is that imaginary and irrational, so imaginary and irrational roots come in pairs. So for an imaginary, let's say that x equals, they tell you there's a root at 3i, okay? Well, they're like twins, but they're conjugate pairs. So if x equals 3i, then x must also be -3i. There must be roots at 3i and -3i. Okay? They are always a pair. Same with irrational roots. Let's say that you have a root at 2 root 5. Well, you must also have a root at -2 root 5. So when you're writing these functions, you have to keep that in mind. They may only say, root at 3i. Well, you have to remember, if it's at 3i, there must be one at -3i. So let's do an example like that. I'm going to look at example 3 from the text if you're following along. Okay, so if I have roots at 6 minus I and a root at -2, and my leading coefficient is 1 again. Okay, so I know I have roots at 6 minus I, and I have a root at -2. But remember, imaginary and irrational come in pairs. So if I have a root at 6 minus I, I must also have a root at 6 plus I. They come in conjugate pairs. Okay, and now I need to get each of these equal to 0 to get factored form. So to get the first one equal to 0, I'd subtract 6 and add 1 to both sides. So that it's 0 on that side, and then end up with x minus 6 plus I equals 0. So that's a factor. The next one, I just add 2 to both sides. So x plus 2 is another factor. And then on this one, I'd have to subtract 6 and subtract I. So I get x minus 6 minus I equals 0. So there's another factor. So to write this polynomial, leading coefficient is 1. And then I'm going to put my conjugate pairs next to each other because they're much easier to multiply the conjugate pairs first because a lot of stuff cancels out, and then you can multiply it by the x plus 2.